Hey everyone, I'm Zain. I'm CTO of Horizen Labs, and I'm going to talk to you guys about one of our projects called zkVerify. The three beats will be a background context, the technical core, and what we believe for the future. So this is an infographic from Digital Information World back in December 2023, so it's about a year old, but it shows how much data is being put into the world every minute of the day. Just some highlights: 46.1 million WhatsApp messages. Oh, sorry. Thank you. Yeah. This is an infographic from Digital Information World 2023. So the numbers are probably off by one magnitude or more, but that's how much data is generated in every minute of the day. It's continuously generated. Just some highlights: 46.1 million WhatsApp messages, 241 million emails, 102 megabytes per person, 360K tweets, all within a minute. And this number for ChatGPT prompts, I'm sure it's much higher now. But yes, there's this explosion of data, and it's continuous, overflowing, and it's coming from all these different sources. We have Web3, which we're a big part of right now in the movement. We have Web2, and then some folks have called this Web4 with artificial intelligence, IoT, and augmented and virtual worlds. At the same time, we're seeing this Cambrian explosion of proofs. The Starkware team has used this terminology and really done a great job with categorizing all the different types of proofs, and we're seeing it at every conference. There's like every quarter, 12 new research papers, new different proof types, and yeah, we're really in the middle of it. There's this ZK researcher from Soundness Protocol. He had this idea of this like continuous stream of proofs. He called it continuous proofs. So he viewed a future where, just like there's a continuous stream of data that's overflowing, every minute of day we believe that there's going to be proofs generated again and again. Just same diagram, but with the same sources, but this time continuous and overflowing number of proofs. So at zkVerify, we want to process these proofs and we want to verify them. So what is zkVerify? It is a modular layer that focuses solely on verifying proofs at scale. Why did we decide to do this? We decided to do this because of developer flexibility. Just all those proofs happening, proof types that are being added all the time. We wanted developers not to think about it. We wanted them to pick the proof type that best suits their needs without worrying about the underlying verification infrastructure. There is a lot of innovation happening, and every one of us is part of that. We want to be that enabler for continued innovation and want to be able to adopt newer proof types. The third is cost efficiency. By solely focusing on verification, we're able to look at different ways to solve for cost efficiency. In terms of the greater ZK narrative, this is how we fit in. This is a ZK map from last month at ZK Summit 12. We're here under verification and aggregation with a lot of other very talented folks. So this is the second beat. I'll go through the technical core. From a high level, zkVerify is an L1 blockchain where its sole purpose is to verify proofs at scale. It doesn't have an EVM. We chose the substrate framework, which is written in Rust, and our core design principle are these modular palettes. So what are the inputs to this, to our blockchain? It could come from all different types of ZK apps, including Web2. We are in testnet right now. We're in incentivized testnet. These are some of the proof types we support: GROS16, Flonk, proof of SQL from space and time, ZK Syncs Era, RIS0 Stark before it gets aggregated and converted, and Ultra Plonk for Noir. And we're continually adding new proof types. The output, the first type of output is this rapid, low latency receipt. It's unaggregated, so as an example, any of these apps would make a call and they immediately get a response. We have a TypeScript library. It's available at npm called zkVerify.js, which I'll talk a little bit more about later. We also have this receipt of aggregated verifications, and this currently in our testnet goes towards the various chains. That includes Ethereum, Sepolia, Ape Chain, Curtis, which is an Arbitrum Orbit L3 chain, our own EVM testnet, Eon, and any new chains that we decide to add. From a holistic view, zkVerify is a public decentralized verification layer at scale. And I'll go really quickly into 3 key technical components, which is the L1 framework for verification, secure receipt broadcasting, and the data structure that represents the aggregated receipt. So first, the L1 framework for verification. So why the L1 blockchain? We wanted to have all the benefits that comes with a blockchain, which is censorship resistance. This is a publicly accessible record of all the proofs that have been verified. And for all the nodes that join a network, we wanted to create this decentralized incentive model for verification. If we were to zoom in on one of those nodes, it would look like this. This is a zkVerify node. It has the traditional substrate setup with the node client, which contains all the outer node services and that handle network and infrastructure activity, and as well as the runtime, which is upgradable WASM. Double-clicking a little bit closer, you see on the left the core networking, consensus, storage mechanisms, and on the right is the runtime. It is a proof of stake chain. For block authoring, we use Babe, block finalization, Grandpa, and yeah, we added these proof verification palettes. So those are the palettes in the runtime client that I mentioned before. We are in the first process of adding these node acceleration palettes as well onto node client side, which includes ArcWorks extensions, substrate primitives for elliptic curves. And many of you already may know some of these like cryptographic operations behind each of these verifiers. I won't go through them in detail, but what we want to do is to have it be developer's choice. We want diverse verifiers for different use cases where a developer can come in and say, hey, maybe I want something that's a proof that's smaller and faster for common use cases, or maybe I want to do something that's proof of SQL related to verifying data queries. Or maybe you might be using a zkVM like RIS0, Succinct, or Jolt, but not have to worry about writing a verifier contract for it. So that was the first part, which is the L1 framework. I will go through the receipt broadcasting. This is from ZK Hack Montreal. Back in August, we had a bounty there, and this is Zgate. That's winner one of our bounties. What they did was essentially a Telegram app that had gated access to Telegram chats. It is a crypto-adjacent Web 2 application where it would only allow access to a user if they had specific on-chain assets. They generated a RIS0 proof of ownership, and they verified it with zkVerify, where they didn't have a Solidity smart contract. They use decentralized verification only with zkVerify. And it was with that rapid receipt, that first type of output that we had mentioned before. Yes, we have now this TypeScript library, zkVerify.js, where clients can make the RPC call submitting their proof and have different event listeners attached to it when the verification has been finalized, included as a block, or if any errors have occurred. I'm going to talk about the second type of receipt, which is these aggregated verifications. This is the verifications going across the different chains. We're currently working with a bridge provider called Hyperbridge. They have this ISMP protocol, which is Interoperable State Machine Protocol. They use various interoperability proofs, and they have a decentralized relay layer network. We're constantly working to improve on this cross-chain receipt broadcasting, but this is our first iteration on it. So what does the aggregated receipt look like? So I'll go into the aggregated receipt data structure briefly. So that's here shown as receipt RJ. It's a really simple data structure where it essentially is a Merkle root hash of a Merkle tree that contains the proofs as its leaves, and it's just this really natural aggregation for heterogeneous proofs. We're also looking to improve this as well, where we're looking at more recursive aggregation, but we know that different applications have different trust assumptions, so this is our first take at it. So yeah, that's the summary of all three components. We have the public decentralized verification at scale, holistically. The first one, which is the L1 component. The second one, which is the receipt, and then, the kind of like broadcasting of the receipt, and then the receipt data structure. Looking ahead. We believe that ZK is bigger than Web3. And those are where ZK is at the center here. I think there's a little bit of a, not a typo, but kind of like a formatting issue, but ZK Tech at the middle of it, at the center of this universe where more and more use cases are being discovered. And I think that it's going to be, and many of us here as well believe that ZK is really just a budding area. We believe the future is this continuous stream of proofs every minute of the day, just like that explosion of data. This is our roadmap that we've gone through in 2024. We're currently in incentivized testnet, and we're in our phase 2. So yeah, come build with us, find out more. We have a booth outside. We also have a grant program. I'll have links to it after this. And we've been part of various hackathons, including ZK Hack Montreal that I mentioned earlier, ETH Warsaw, ETH Sofia, and the upcoming ZK Hack V, which is virtual. These are our contacts. Horizen Labs. We are also builders on Horizen, the blockchain, which is home to the cryptocurrency Zain. And yes, zkVerify is another project that we're working on. And we're currently hiring as well. Thank you.
Thank you, Zain. Anyone also agrees that ZK is bigger than Web3? Okay. Bullish. Any questions for Zain? Okay. First.
Hey, Zain. A really good talk, especially the verification piece probably gets forgotten a lot after proving that's it. The piece that I'm really interested in is the aspect that you said you support different type of proofs. Do you see a world wherein there is standardization across these proofs that are generated so that you don't have to create these clients for different types of proofs?
Yeah, that's a great question. Yeah, we are part of a consortium called ZK Boost, and yeah, working towards standardization. I think that's true. I feel like it might be on its way. It's just that there's just new proof types all the time, and I think with innovation where it is, it's just continued to improve in that way. But yes, I think standardization would be key in the future. Great question.
Thank you for the great presentation. Just a quick question. So if someone wants to use a Stark proof verified in zkVerify in Ethereum, how would you respond if someone say that it does not have the same trust assumption, zkVerify and Ethereum? Thank you.
Yes, great question, and that is true. It definitely has different trust assumptions, but we also know that different apps have different trust assumptions, and so we do cater to that. Definitely something that's verified on Ethereum will have way stronger trust assumptions, but we don't say, hey, everything needs to be verified on Ethereum, and that's our personal take.
Thank you.
Anyone else? Impressive, guys. Great questions. Okay. Thank you, Zain.
Thank you, everyone.
Thank you.